I keep hearing about the overwhelming amount of health benefits that vitamin K provides, but I'm worried about creating blood clots. Vitamin K is needed for blood clotting, right? So if I take too much, aren't I going to make my blood thicker and increase my chance of creating a potentially life threatening clot? Have you had these thoughts or worries? Well, if you have, you've come to the right place. Hi, I'm Danny Curtin. Thank you for joining me today. Vitamin K is needed for blood clotting, but it's also needed for the prevention of excess blood clotting and arterial calcification, while being required for strong bones, robust immunity, and healthy cardiovascular function. In fact, vitamin K is even required for the breakdown of cancer cells. But sadly, most people think that vitamin K is only needed for blood clotting. And with that, they think, or they've been told, that too much vitamin K can lead to excessive blood clotting. Information that's not only false, but can be devastating to your health. You really need to think about vitamin K as a single nutrient that takes part in many different bodily functions. Vitamin K is used as an activator for certain types of proteins. For example, when it comes to bone health, there are bone proteins that allow calcium to be absorbed from the blood and forced into the bones, making them stronger and more dense. But these proteins can only do their job once they've been activated by vitamin K. The same thing goes for blood clotting. You've got many different proteins involved in the blood clotting process, but they can only bind together to form a clot once they've been activated by vitamin K. Activation is key. This is the point that I really want to hammer home in this video. Not only is vitamin K one of the most important nutrients you should be taking, but you should also be confident that this nutrient does not thicken your blood or increase your risk of excessive blood clotting. So let's say I cut my arm and it's bleeding. In order for that bleeding to stop, 7 different proteins need to stick together and to the injured tissue to form a clot. The thing is, in order for that process to start, my body needs some type of evidence that there's an injury, because it definitely doesn't want to start the clotting process if it doesn't need to. So what's that evidence? Well, you might think the cut on my arm would be enough to start the process, but it's technically not the cut. It's actually a very specific protein called factor 3, which is never in my blood. However, when the cut occurs, factor 3 winds up in my blood. And this is the first step that supplies adequate evidence to start the entire cascade. Now that factor 3 is in my blood, it gets recognized by another clotting protein, factor 7. Now remember, these proteins need to stick together, but they can only do so once activated, which is where vitamin K comes in. In this scenario, factor 7 circulates to the liver and is activated by vitamin K, which creates the activated form of factor 7, factor 7A. Factor 7A can now stick to or bind to factor 3 and the injury site, and the coagulation process continues on, each step in the cascade stimulating the next step, with vitamin K directly or indirectly activating several clotting proteins so they can stick together until you have a beautiful and stable fibrin-based mesh and the bleeding has stopped. Since this was an external injury that started on the outside of my body, it was an example of the extrinsic coagulation cascade. But clotting doesn't always originate with some type of bloody injury on the outside. When coagulation begins on the inside, we've got the intrinsic cascade. For example, imagine I have high blood pressure. We know that over time, high blood pressure puts a lot of stress on my entire cardiovascular system. And eventually, I could start to develop small injuries on the lining of my blood vessels. Basically, microscopic tears that need to be repaired. Otherwise, I could start to internally bleed, or I could suffer from something worse, like organ damage. In any event, the tears in my blood vessels expose factor 12 to the connective tissue that's directly on the other side of my blood vessel wall. Without injury, factor 12 is never outside of my bloodstream, but these tiny tears allow it to be, and this is the evidence my body needs to start the intrinsic cascade. Similar to the extrinsic cascade, there are many different proteins that need to stick together and to the injury site to form a clot, with vitamin K activating or making them sticky in the liver. It's also important to point out that while all of this clotting is going on, in both of these examples, anticoagulant proteins like protein C and protein S are working at these sites as well to prevent excessive clot production. However, protein C and S are also vitamin K dependent, which means they can only do their job once they've been what? Can you guess? That's right, once they've been activated by vitamin K. So you can see that while vitamin K is essential for blood clotting, it doesn't directly cause clotting. Instead, it enables clotting proteins to stick together to form a clot when needed, and it's just as important for anti-clotting as well, as it enables anticoagulant proteins to break down excessive and eventual unneeded blood clot material. I like to analogize the clotting factors involved in the coagulation cascade as bandages that are always circulating in the blood, but they don't have any adhesive, so they can't stick to anything. As soon as there's an injury, vitamin K is the activation tool used to make the bandages sticky. And once there's enough clotting material, or the clot isn't needed anymore, vitamin K inactivates those bandages by taking away their sticky adhesive. The key point in all of this is that vitamin K is only an activator and it doesn't activate on its own. There has to be evidence that clotting is needed, which can only happen when very particular proteins are detected in parts of the body where they don't normally exist. You either have enough vitamin K and the entire cascade will proceed, or you don't have enough and you will not be able to clot. In fact, several studies have examined the effects of vitamin K supplementation on blood clotting. Researchers from the Department of Hematology at North Sichuan Medical College in Nanchang, China, concluded that vitamin K2 supplementation does not affect the activity of vitamin K dependent coagulation factors in healthy individuals. In fact, it maintains the hemostatic balance without altering clotting times or levels of coagulation factors, while being highly beneficial for bone and cardiovascular health. And finally, researchers in the Netherlands have concluded that, quote, excess vitamin K intake cannot result in more clotting factor activation. This has been demonstrated within our institute in thousands of subjects taking high doses of vitamin K over several years. Even when monitored with the most sensitive techniques, increased clotting tendency was not found in any of the participants. An exception to this is formed by patients receiving oral anticoagulants like warfarin or other vitamin K antagonist drugs. And herein lies one of the reasons so many people think that vitamin K is a blood clotter, since one of the oldest and most popular blood thinning medications, Coumadin, or its generic name warfarin, works by inhibiting vitamin K and the activation of clotting factors. Many people have assumed, even physicians somehow, that vitamin K itself promotes clotting. But as you are well aware of now, this is an unfortunate assumption. And it's even worse when you think about some of the other benefits of vitamin K, like the fact that vitamin K activates osteocalcin in the bones. Osteocalcin is a bone protein which allows calcium to bind to bone, lowering the risk of osteoporosis and other bone issues. Vitamin K also activates MGP in the blood. This is the protein so many of us are interested in because MGP prevents arterial calcification by keeping calcium dissolved in the bloodstream. But MGP can only prevent calcium from binding to the arterial walls once activated by vitamin K. And finally, vitamin K has even been shown to reduce the risk of cancer by activating immune-regulating proteins in the liver and blood vessels, proteins involved in cell regulation, an essential process for preventing the proliferation of mutant cancer cells. Whew, we made it. We finally reached the time to discuss the differences between vitamin K1 and K2, which many of you will be surprised to learn has more to do with where they are absorbed and available in the body versus their assumed individual functions. Now, vitamin K1, also known as phylloquinone, is formed in plants, and important sources in our diet are green leafy vegetables such as spinach, broccoli, Brussels sprouts, and kale. The problem with K1 is that it is not easily absorbed. Depending on the source, we are only able to absorb between 3 and 5% of the K1 we get from our diet. However, supplemented K1 does not have this problem. For the most part, vitamin K1 is absorbed directly into the liver. If you remember, the first action of vitamin K in the coagulation cascade was to activate clotting factors in the liver so they can stick together. Since that activation occurs in the liver, vitamin K1 is typically involved in this process. K1 is more efficient at activating clotting factors because it's already in the liver, but this process isn't exclusive to vitamin K1. Now, vitamin K2, or menaquinone, is found in fermented foods like natto, cheese, and sauerkraut, as well as in animal products such as meat and eggs. Now, unlike vitamin K1, vitamin K2 is more stable in the blood and is easily distributed to other tissues in the body, like the bones. Vitamin K activates osteocalcin in the bones, and MGP is activated in the blood, which means vitamin K2 is more efficient at supporting bone health and preventing arterial calcification since there's more vitamin K2 in the blood, where these proteins are activated. So, in the end, for healthy individuals that aren't taking blood thinning medications, vitamin K is not a blood clotter. Instead, it's a multifaceted nutrient essential for a variety of critical bodily functions. K1 and K2 play vital roles, not limited to just one function. K1 is primarily involved in blood clotting, and K2 is crucial for bone health. However, their functions are interconnected. If there's insufficient K1 in the liver, K2 in the blood can compensate to support clotting. And similarly, K1 can assist in bone growth or calcium utilization if needed. The point is that adequate intake of both forms of vitamin K is essential for reducing the risk of osteoporosis, cancer cell growth, and cardiovascular disease. Current scientific evidence supports the safety and necessity of adequate vitamin K intake for overall health. And by dispelling the myths and misunderstandings about vitamin K, we can appreciate its full range of benefits and ensure that individuals can make informed decisions to incorporate this vital nutrient into their diets. If you enjoyed this content, please make sure to like it and share it with your friends and family. And don't forget to subscribe to the channel. Again, I'm Danny Curtin. Thanks for watching. I'll see you on the next one.